Hello once again to our listeners. Happy Eid Mubarak and welcome back to the 8th episode of the IVSA Kelantan podcast show. Today we have with us Dr. Ruhil Hayati binti Hamdan from University Malaysia Kelantan as our guest speaker for today's episode. Dr. Ruhil graduated from University Terengganu, Malaysia with a degree in Biodiversity Conservation and Management and later furthered her masters in Aquatic Animal Health. She later pursued her PhD in Aquatic Animal Health in University Putra, Malaysia. Dr. Ruhil currently works as a lecturer here in University Malaysia Kelantan under the Faculty of Veterinary Medicine and she specializes in fish health. Today, she is here with us to talk about antimicrobial resistance, which is an interesting topic in both medical and veterinary field. Hello, Doctor. Welcome to our 8th episode today.
Hi, Jaya.
How are you feeling today, Doctor?
Feeling nervous?
Okay, don't worry. We'll go it very easy, very openly today. Okay, shall we start off with the first question?
Sure.
Okay, in terms of AMR, short for antimicrobial resistance, how is it progressing in Malaysia?
So, on a global scale, antimicrobial resistance is recognized as a One Health challenge due to the continual and increased development and distribution of resistant microbes and genes among humans, animals, and the environment. So, there is a major drawback in terms of the lack of research assessing the coexistence of AMR in this sector. So, extensive research highlighted food animal manufacture structures that are likely to harbor reservoir or promote transmission of AMR in addition to increasing human colonization with AMR commensal bacteria. So, numerous antibiotic stewardship policies have been designed and implemented in medical practices and animal husbandry in high and middle income countries. So at our national level, Malaysia has published an action plan, namely Malaysian Action Plan on Antimicrobial Resistance, MyApp-AMR, through a collaborative effort between the Ministry of Health, MOH, and Ministry of Agriculture and Agro-Based Industry, MOA, Malaysia. In this action plan, a few other departments were included. So, on animal aspect, the Department of Veterinary Services, DVS, and National Pharmaceutical Regulatory Agency, NPRA, are involved in the One Health approach. So, for environmental aspect, were represented by the Pharmaceutical Services Division, PSD, under MOH. So, the bodies involved in the Malaysian One Health approach are the Division of Fisheries, DOF Malaysia, and then Ministry of Higher Education, MOHI, with Malaysia One Health University Network, MyOHUN. So, others like Medical Development Department, and then Health Education Communication Center, and then our IMR, Institute of Medical Research, Food Safety and Quality Division, and many more. So, however, we still need research concentrating on high income setting, attitudes, emotion, and belief on the utilization of antimicrobials remain underexplored in lower and middle income countries like Malaysia. So, microbiological and epidemiological and social science exploration are required at community and farming across the One Health range to fill the gaps in information and knowledge of AMR.
Okay, thank you, Doctor. So, which industry is most concerned in contributing to AMR in Malaysia?
Actually, humans, animals, and the environment mostly to contribute to increase the AMR, but our livestock industry is the most contributor to AMR. So, as antibiotics are widely used in healthcare to treat or prevent bacterial infection, and then as growth enhancer, therapeutics, and metaphylaxis in animal husbandry, and then transmitted in the environment through irrigation using wastewater or inappropriate disposal and treatment of human and agricultural waste.
Okay. The next one will be what are the commonly used antimicrobial agents in livestock and how do they affect the usage of these in human therapies?
So, in Malaysia, all antibiotics indicated for disease treatment and metaphylaxis are regulated by NPRA, National Pharmaceutical Regulatory Agency. So, which is the Drug Control Authority of Malaysia under Ministry of Health. So, whereas premixes that contain antibiotics for disease prevention and growth promotion are under control of the Department of Veterinary Services (DVS) under MOA. So, in accordance to the Feed Act 2009. So until up to November 2017, there are 458 antibiotics that registered for use in livestock. So for the group of the drug, there are aminoglycoside, amphenicol, beta-lactam, carboxylic, cephalosporin, and then fluoroquinolone, lincosamide, microlide, and then autosomycin, fluoromucilin, polyether, polymyxin, septogamin, and then sulfonamide, tetracycline, and then there are combination drug containing timetoprim and other combination drug that contains more than 2 antibiotics. So, however, this registered antibiotic that fall under WHO criteria of critically important antimicrobials. So these antibiotics are identified by WHO as critically important for human health, and their use should be restricted in veterinary sector. So the antibiotic that include in this list, which are ampicillin, amoxicillin, cefadroxil, chlortetracycline, doxycycline, erythromycin, flomycin, gentamicin, neomycin, oxytetracycline, spiromycin, sulfadiazine, and sulfadimetoxin.
Okay, thank you, Doctor. Next, I'll pass it to Ashley for the coming questions.
Hello, doctor. So
Hi.
as well known, there are many ways which we can test the level of AMR, and one of them is AST, which is the antimicrobial susceptibility test. What is your opinion in using AST for making a reasoned and sensible decision of an antibiotic treatment for farm animals? And do we have any other methods which are less expensive or more convenient for farmers?
Okay, actually, standard growth based technology based on this diffusion and broth dilution still dominate in antimicrobial susceptibility test. So actually they are slow and require pure cultures, but in other aspects serve the purpose well. So only few rapid growth-based AST method work directly with polymicrobial clinical sample, which is required in point-of-care technique.
I see, doctor. So moving on to the next question. Livestock aside, are there any aquatic species or populations that are greatly affected by AMR?
Sorry, can you repeat?
It's okay, doctor. Aside from livestock, are there any aquatic species or populations that are affected by AMR?
Okay, as we all know, aquaculture system and farms have been designated as genetic reactors or hotspot for AMR genes. So, where significant genetic exchange and recombination can occur, which can shape the evolution of future resistant profile. So, it has been estimated that 90% of bacteria originating in seawater are resistant to one or more antibiotics, and up to 20% of the bacteria are resistant to at least 5 antibiotics. So once these bacteria acquire AMR genes, they may exist for a long time in the environment. So even the selection pressure ceases. So finfish and shellfish that have been cultured in this environment prone to expose to AMR. So a great concern for bivalve species such as oyster, mussels and scallop because this organism is filter feeders. So this organism will filter any particle in the water.
Okay, so doctor, you mentioned about how bacteria in seawater gain AMR, and I would like to ask how would proper livestock sewage disposal and improper disposal of antibiotics affect water quality for aquatic animals?
So as we all know that after this antibiotic entering the water ecosystem, so they have the ability to change the structure of the microbes and can vanish many species of microorganisms, including taxa that responsible for carbon cycling and primary productivity. So, for an instance, the presence of antibiotic pollution in aquatic environment was shown to lead to an increased frequency of toxic cyanobacteria species. So, this cyanobacteria will cause eutrophication and then will cause low or dissolved oxygen. So, as we all know that antibiotic residue also will accumulate in the body, including muscle tissue, blood, internal organs, and the eggs. So, even the food animals that are given antibiotic must go through a withdrawal period before the products are sent to the market. So, the level of antibiotic residue detected in the food product must not exceed the legal permissible level. So, which is also known as maximum residue level MRL. So our consumer should have cognizance of the fact that antibiotic residue may lead to emergence of antibiotic resistance which could possibly be transferred to man and result in treatment failure or clinically significant infection. So the higher level in the river ecosystem also can cause various infection to animal as well as human beings.
All right. I'm glad to know that there are measures in place to help combat AMR in Malaysia. And thank you for your insights, Doctor. Unfortunately, that is all the time that we have for today. We have come to the conclusion of today's podcast session. AMR is one of the prevalent issues in the Malaysian veterinary community. As we have learned from our discussion with Dr. Ruhil today, farms and livestock are not the only fields affected by AMR, as it also affects aquatic life. I believe AMR also affects other aspects of our lives in many ways. Therefore, we should be aware of the severity of the impact of AMR as it involves all of us. Thank you so much for your time today, Doctor, and thanks to the team for making this project possible. For those of you who are listening or watching right now, thank you so much too. Do look out for future episodes and Happy Eid Mubarak to all those who are celebrating.
Thank you, Jaya and Ashley.
Thank you, Doctor.
Good.